All right, guys. So I decided kind of the most efficient way to do these videos, instead of you waiting for me to write everything down, I just went with my kind of already filled in version, and I'm gonna talk you through that. Okay, so this first one says, are some groups underrepresented? So this is hypothesis tests for P1 minus P2. Another way to think of that is the difference, right? Difference is the name of a subtraction problem. So difference between proportions. Okay, so according to phys.org, Black and Hispanic females are underrepresented in STEM programs compared to non-STEM programs. A certain university would like to see if this is true for their student population. They took a random sample, and so instantly I'm thinking, that's important, gonna underline it, of 300 STEM students, and found that 12 were Black or Hispanic females. And obviously I underlined what's important there as well. So before I do anything else, before I continue reading, I'm thinking I have a proportion. 12 out of 300 are Black or Hispanic females in the STEM program. So I went ahead and calculated 12 divided by 300 is 0.04. And I went ahead and called this P hat 1. Since it was listed first, it's my first sample proportion. So then a separate random sample of 500 non-STEM students had 75 Black or Hispanic females. So I'm thinking, okay, good, this is another random sample, that condition's gonna be met. This is my second proportion, P2 hat, because it's from a sample. These are non-STEM students, so they are totally separate from my STEM students. And it was 75 out of 500. Would give me 0.15. So I'm already thinking, okay, the STEM proportion is quite a bit lower than the non-STEM proportion. So I'm thinking there's a difference. I have some evidence of a difference. But the question is, do the data provide convincing evidence that Black and Hispanic females are underrepresented in STEM programs? Use a 5% significance level. And so I also want to, kind of break down that underrepresented, right? Underrepresented would mean that there are not enough of them. So the proportion, it seems, in STEM programs is lower than the proportion in non-STEM programs. So we're going to see if the difference between those two samples is big enough or is significant enough to say that there actually is a difference in the whole population of students. And of course, this must be a pretty large university to take a random sample of 300 and 500 students. Fontbonne, I think that we have like 3,000 students, I think, in the population. And so this would be pretty large samples to be taking from Fontbonne. But if we're thinking about a school like, the University of Missouri, where they have, tens of thousands of students there, this is not that big of a sample for them. Okay, so let's go ahead and get started. You know the steps for a hypothesis test. And of course, I know this is a hypothesis test and not a confidence interval because it's asking, do the data provide convincing evidence? And I'm told to use a significance level. So I'm not told to estimate the difference. I want to know if there's a convincing evidence that there is a difference. So I'm going to do a hypothesis test. I'm going to start with state. So I'm going to state first the parameter. And this is a little bit different. So I've got P1 minus P2, right? That was in our notation in the presentation, P1 minus P2. And I have to tell what P1 and P2 stand for. So I just want to caution you now. I noticed on the last test, some of you are using P all the time for your parameter. P does not stand for parameter. P stands for proportion, right? So only when I'm talking about proportions, when I'm talking about so many students are Black and Hispanic out of a total number of students, right? Whenever I do not have quantitative data. Here the data is their ethnicity, right? Black or Hispanic. And I guess also their gender. It's not a number. Whenever I'm talking about quantitative data, I'm looking at means, and then I use mu. So just be careful. We really do want P1 minus P2 here, but in the future, we might need mu1 minus mu2. Okay, so it's equal to the true difference. And I use this word true instead of saying the population difference because true is a shorter word. You could also say the population difference. But this is the true difference in proportions of Black and Hispanic females. And then I have to specify in STEM and non-STEM programs. So I'm specifying between my two populations. The first population is STEM, the second population is non-STEM. And this is what students often forget to do. You have to state the way that you're going to subtract. It's usually assumed that you're going to subtract the first one mentioned minus the second one mentioned, but make sure that you go ahead and state that. Okay. So when I say P1, I'm referring to STEM. When I say P2, I'm referring to non-STEM. So then my statistic, that's from my sample, is going to be the difference in my sample proportions. So P1 hat minus P2 hat. And I already calculated what P1 hat is. It's 0.04. What's this over here? Minus 0.15 from up here. So I get negative 0.11. Make sure if it's negative, you put that negative in there, right? That means that the first population is lower than the second population, or is less. Okay, the other part of stating is, of course, then to do the hypotheses and the significance level. They told us to use 5%, so that's alpha equal to 0.05. And then my hypotheses, for differences, you will always have the null value that the proportions are equal to each other, that the population proportions are equal to each other. So P1 equal to P2, we often don't write it this way. This is the way it'll appear in StatDisk, but we usually write it as a subtraction. So if I subtracted P2 from both sides, I would get P1 minus P2, and if I subtract P2 from P2, I get 0. So P1 equals P2 is the same thing as saying P1 minus P2 is equal to 0. That's always going to be my null. Okay, I'm always going to assume that the difference is nothing, that they are equal to each other. Now, my hypotheses are kind of tricky. I have to read the wording of the question to decide whether I should use less than, greater than, or just not equal to. But in this case, it said underrepresented. So that makes me think that P1 is going to be less than P2. STEM proportion is less than the non-STEM proportion. And again, I subtract P2 from both sides to get everything on one side to make it a difference. So P1 minus P2 is then less than 0, keeping my symbol the same here. And that is my alternative hypothesis. Okay, so that's everything that I need to state. Be careful when you write those hypotheses. So the next part is to plan. We're going to name the procedure. Guess what? It's now a 2-sample test for P1 minus P2, right? In the past, our hypothesis test had been 1 sample test for P. Now we have 2 samples and it's the difference, P1 minus P2. Okay, then we need to check the conditions. So they both have to be random samples. That was stated in the problem. Check. The samples are independent. So that means that they don't have any connection between each other or to each other. And there is nothing in the problem statement that makes me think that those 300 STEM students are connected to the 500 non-STEM students in any way. And there's a different number between the samples, right? One has 300, one has 500, so they couldn't have a one-to-one connection between each student. So these have to be independent. So that's met. And then I have to check that, and maybe I'll even write in here what I'm checking. Oops. So the number of successes and the number of failures are all greater than or equal to 5. That's what I'm checking here. Okay, so remember the number of successes is the sample size times the proportion. So I take my first sample size, 300, times the first proportion, P1 hat, and I could literally type out 0.04 times 300, but I know that's gonna be 12, right? 12 is the success, what I'm interested in. It's the number of Black or Hispanic females in that sample. So 12 for the first one. And then I have N1 times Q1 hat. And again, I could literally say 300 times what would it be? 1 minus 0.04 is 0.96. So 300 times 0.96. But it's faster to say, I know what 300 minus 12 is, right? If there are 12 Black or Hispanic females, that means 300 minus 12, or 288, must be everyone else. So that would be my failure in this instance. Of course, it's not a bad thing. It's just the opposite of what I'm interested in. Same thing for the second sample. The number of successes is 75. There were 75 Black or Hispanic females, meaning 500 minus 75 is 425 non-Black or Hispanic females. And all 4 of those numbers, right? This one, this one, this one, and this one, they are all greater than or equal to 5. So that condition is met as well. Okay, so then I can move on to the actual do step. So my tech inputs are what I start with. I go to StatDisk and I have to enter several things. This is similar to what it is for just one sample. You have to tell what alternative hypothesis you want. So we wanted that the first proportion is smaller than the second proportion. So we choose P1 is smaller than P2. And when we look at, I'm going to try to make this clear for you guys. Let's see, maybe I will zoom a little bit. That's a little bit better. So when I go to analysis, hypothesis testing, proportion to samples, I'm looking here, population proportion 1 not equal to, population proportion 2, that's not what I want less than. And then I have to enter some more stuff. So alpha is equal to 0.05, that's correct. My sample size this time is 300, my first sample size is 300. The number of successes was 12. My second sample size is 500 and the number of successes was 75. So I wrote all of that down here. Significance level, N1, X1, N2, X2. Okay, and then when I hit evaluate, I get here my test statistic, Z, is negative 4.83, which I can tell when I look at to find the area on a normal curve, that's going to be a very, very small probability. So my p-value, it's not 0 exactly, or it would just say 0. It must be some very, very small decimal that when you round to 5 decimal places, does not have any significant digits. So we write that down as 0 plus. Okay. 0 plus. You can also write it down this way with 5 zeros. I'm fine with that. But 0 plus, or one other way to write that is to write approximately 0. All of those are fine with me, right? That squiggly line means approximately. It's very, very close to 0, but it's not actually 0. Because if it were 0, it would be impossible. It's not impossible here. It's just very unlikely. So then our conclusion is the same for all hypotheses. We start out with since the p-value equals, in our case it was 0 plus, that value is less for sure than alpha, equal to 0.05. If that's the case, if the p-value is less than alpha, we reject the null. So that means if we reject the null, that we do have convincing evidence that Black and Hispanic females are underrepresented in STEM programs. And that last part I literally got from the original question, okay? But I also wanted to put on here, so I put it in orange and in parentheses, that it's okay to phrase that based on your hypothesis. You can basically change this into words. You can say, we do have convincing evidence that the proportion of Black and Hispanic females in STEM is less than the proportion of Black and Hispanic females in non-STEM. That's what it means for them to be underrepresented, right? So you can choose how you want to write this. Oh, and I got a little bit lazy as I was writing this, so I abbreviated Black and Hispanic. So that's what that stands for. Okay, so I'm going to do another video on the confidence interval on the back to try to break it up a little bit for you guys. So I'll see you on the next one.